What will you learn about in the graphs lesson? You'll learn about what a graph is, so let's go take a look at a picture. A graph is a set of nodes, though when we talk about graphs, we regularly talk about each of these nodes as a vertex. So the plural of vertex is vertices. So we have a set of vertices, and those vertices are connected with edges. This is something called an undirected graph because for each of the edges, we can follow that edge in either direction. So the edge between nodes 4 and 42, we can follow from node 4 to node 42 or from node 42 to node 4. In a directed graph, edges actually have a direction. So if we had an edge between 4 and 42, that edge could only be followed from 4 to 42 or from 42 to 4, depending on where the head and the tail of that edge was. This is also an unweighted graph where the cost of following each edge in the graph is identical to the cost of following every other edge in the graph. We will often find it's useful to have a weighted graph instead, where each edge has a particular cost. It's pretty common to make the cost be the distance between those 2 points in the game world. If we're implementing a pathfinding algorithm to navigate through the game world, and in fact, we might even add something to the cost of edges that traverse harsher terrain, for example, if you have to go up steep slopes or cross rivers or those kinds of things. So we'll also find it useful to have weighted graphs where the edges have costs associated with them, but that's not the kind of graph that we're looking at here. We'll learn how to implement a graph, and we'll evaluate the algorithmic complexity of the operations in our graph. We'll then revisit dictionaries, which we looked at briefly in the previous course, but we'll look at them in more detail here so that we can use them to search a graph, because we regularly are looking for a path from a start node to an end node in our graph, and that's not surprisingly called pathfinding, and dictionaries will help us do that.